if you think about the way that data sources are represented today, it's all in terms of data storage primitives, right? It's actually for the convenience of the data system. It has nothing to do with the data that's being represented. So the way that Palantir systems begin is actually with a, it's like a schema, but it's what we call an ontology, and it's human conceptual. It's the real world objects, the real world things, the way that people think about the problem. And we plug in each of the data sources, map them into virtual objects, and then build user interface on top of that, which lets the people who know the most about the problem get direct access to the data. So we use a bunch of these big data technologies that you've heard about, and we use them sort of under the covers inside our stacks. But in some ways, it's kind of a phrase that we love to hate, because big data is big tools for programmers. It actually doesn't really bring, it gives you sort of a reach and a scope that you can't have using sort of traditional databases. When you can go sort of big and parallel and do things like MapReduce, you can do processing on a scale that you couldn't do before. But all that does is give your programmer something better to go with. That same researcher at the CDC isn't about to write a MapReduce job, right? So their interface to it is still some other person in some other group, some programmer who has to kind of explain what they want, and then the thing has to be written over a couple days, and then it runs, and the answer is 42, and they go, wait, but you forgot about this, right? And so the way that we deal with this is actually by building interactive data fusion platforms. And there's a lot of information about this on our website. What I'm going to do, though, without going into a lot of detail, is reconfigure things here real quick and show you a quick demo of actually a fraud workflow, which will give you some sense of what it's like to be an analyst using one of these systems, right? So let's see, let's do this. And everybody can see, yes. Okay, so what you see here is the user interface for what's called Palantir Gotham. It used to be called Palantir Government. We renamed it when we started going to commercial banks, and we were like, we have this great product for your anti-fraud problem at your bank. It's called Palantir Government. And they go, what? But it really has nothing to do with government. It's actually just all about dealing with sort of discrete objects in the world and the relationship between them. So in this scenario, I'm actually playing the role of a fraud analyst. It's actually fairly analogous to the PayPal workflow I was talking about. There's some sort of automated recognition system that's flagged a group of suspicious transactions and is queued up for me to go figure out what's going on. Is this actually fraud? So I take these, and the data sources here are information coming off of the web servers at a bank, right, about who's logging in and what they're doing, like what are the cookies, what IP addresses are they coming from, and then also the information inside the transactions, inside the accounts, like how is money moving through different accounts. So here what I'm looking at is actually 3 accounts in the online bank, or 3 logins. And what I can do is start querying this data, just sort of drilling down in to see what's going on. So here I'm going to say, well, what events are actually connected to this? And what comes back are 3 cookie-based sessions. So that's what these Firefox icons are, just sort of cookies on the bank. And what's interesting here, and probably what flagged the recognizer, is that these cookie sessions are being sort of cross-connected to these accounts, right? Which could be a pattern of fraud. It could also just be like, say, an internet cafe where people forget to log out of their browsers. So it's not really definitive. So I'm going to keep on going. And let's say our security people are doing some kind of fingerprinting based on the information coming in from the network. And they can sort of say, how many computers are these connected to sort of decide whether or not it's behind a NAT boundary or something like that. So here in this case, these 3 sessions are actually connected to just 2 different computers. And so that's starting to look a little weird. And what I'm going to do is actually pivot out from the sessions and say, well, these 3 sessions, what other accounts have they touched? And so by looking at the log data, what I can see is that actually there's 59 different online profiles that have been touched by these 2 computers, right? So we can construct some scenarios where this is actually completely reasonable. Maybe you have a class and they're doing some kind of bank simulation, they open real accounts, they move a little bit of money back and forth, and they only have 2 computers in the classroom. That's it, right? Okay, fine. So we need some other dimension to be able to understand what's going on here. So what I'm going to do is actually look at the IP addresses here. So I'm going to actually take these IP addresses and drag them to the map. And they were sort of geocoded when they came in. And so they should pop up on the map here. And I can sort of zoom in and see what's going on. And what we see is an interesting pattern emerge. So if we remember, there's only 2 computers involved here. But there's something like 7 or 8 different locations. And in fact, a bunch of them are in Nigeria. So when I start looking at this at a time-based view, if I just select the ones that are Nigeria, what I see down here, this is a timeline. And so if I zoom in here, what I can see is that there's sort of like a strobing effect where there's an axis from Nigeria and then from the US. So let's find a theory that fits the facts here. So maybe Starfleet has parked an asset in orbit, and it's using its transporters to rapidly move computers from one area of the Earth to another, and then they're logging into an online bank. That would fit the data if there were starships and transporters, right? A better theory is that there's a bunch of people in Nigeria who are ripping people off. And what they're doing is they're actually using proxy servers to cover their tracks. And sometimes they can't connect to the proxy server, or they just don't really know what's going on, or they forget to click the button. And so the access actually looks like it's coming from the United States. But we have a pretty good idea that there's something bad happening now. Now we just have to figure out what it is, right? So I'm going to go ahead and pull this stuff off the map. And what I want to do is figure out what's going on. So how do I do that? Well, I'm going to go ahead and dive into the online profiles here. And from there, I can actually see which are the 3 or 4 profiles that are the most active, right? So let me grid these up. And as with Photoshop, there's about 10 different ways to do this. I can use selection keys, or I can just use the mouse. In a lot of ways, what we've built is kind of like Photoshop, but for semantic data, right? And what I want to do is actually connect these to the accounts in the bank. And so what comes out is, it looks like this guy's not actually connected to anything. Who knows what's going on there? I can ignore that for now. If I want to come back to it, everything that I'm doing is actually being saved in our sort of associative history, which is something that Vannevar Bush talked about, associative trails in his As We May Think. And if I want to bring this guy back, and I decide that, well, I'm just going to leave him on the graph until later, but now I want to rearrange these guys, what it'll do is it'll actually remember that I did that, and it'll leave that as a branch. Right, so we actually have a branching revision history of everything that we've ever done. And that applies to the data as well. In fact, if you want to take it even one geekier step further, the way that we actually deal with the data in the system is like the distributed version control. By opening this investigation, I've done a copy on write checkout of the consensus view of the world, and all my changes that I'm making here are private. I can import more data, mash it up with what's going on. It doesn't affect anyone else until I hit the publish button. No one can even change the data in my investigation until I hit update. There's a lot of other really cool things that we won't go into here, but I can tell you about them later if you're interested.